So let's continue with trigonometry. We did the basics of trigonometry, which involved a right angle triangle. Now, if we have a shape, we have a triangle other than the right angle triangle, then what do we do? Now, let's use this triangle. Let me label this end A, this end B, and this end C. Okay, so now the side that is right in front of the angle C is called side C. The side that is right opposite or in front of angle A is called side A. And similarly, in front of B is the one which is called side B. Now, these are the three sides and angles that we have for any triangle. We have just named them A, B, C. A, the capital A, B, C being the angles, and the small a, B, C being the lengths or the sides. Now, we'll try to use them to understand few more concepts relating to trigonometry. Okay. First, let's understand the sine rule. I stress on some points and just for your own good. So try to focus on them rather than memorizing the rule itself. Sine rule. Now, what is sine rule? Sine is very easy to understand. One thing that you can clearly observe is that the greater the angle of a triangle, the longer its corresponding side is. If C, I tell you, is the largest angle of this triangle, obviously side C is the longest side. If angle B is the smallest angle of this triangle, side B is the smallest side. So the ratio of a side and the sine of its angle, the ratio of a side and the sine of its angle is always constant in a triangle. Now remember, these things are only needed when we don't have a right angle triangle. If we have a right angle triangle, only SOHCAHTOA or the Pythagoras theorem is enough for us. So now how do I write it? Let's take any side, for example. If I take side A, now the ratio is sine A. So A and sine A, this ratio will remain the same no matter what side or angle you choose. So you can say, sir, this ratio will be equal to B and sine B, or if you would have taken C and sine C, the ratio would remain the same. Similarly, this entire thing can be taken the other way around as well. Sine A upon A will be equal to sine B upon B. So if you keep angle in the numerator, you always keep the angle in the numerator. Or if you keep the side in the numerator, you make sure that only sides are in the numerator. So this ratio stays consistent. This is the sine rule. Very easy. Now cosine rule. Cosine rule is A square is equals to B square plus C square minus 2BC cos of A. Now I urge students to understand just this one. It is, you can call it an extension to the Pythagoras theorem. Just write the Pythagoras theorem, taking one of the sides, and just write minus 2BC cos A. Just if you want to memorize it, this is the one that you should memorize. I don't urge memorization, but if you practice it enough, it will be on your fingertips. But if you want to memorize it, if you're struggling with practicing it, I urge you to write it again and again whenever you use it for any particular triangle. Now you can just manipulate this entire thing and get your angle as a subject. How can you do that? Minus 2BC cos A. Remember, these four quantities are multiplying and it is subtracting over here. So if I take it on the other side, I can write it as A square plus 2BC cos A is equals to B square plus C square. And 2BC cos A is equals to B square plus C square minus A square. So you can write cos A as B square plus C square minus A square upon 2BC. So if you want to memorize it, memorize the first one. And then the second one, you can make it on your own by manipulating the entire equation. Okay. Another thing, whenever you're using sine rule, there are four quantities that are involved. What are those four quantities? You have two sides and two angles. And when you're using cosine rule, again, four quantities are involved, three sides and an angle. I always urge students to look for or to check for cosine rule. Whether you can apply the cosine rule, check for the cosine rule first. Why? Because it is easier to check for. Just check that whether you can apply the cosine rule. If you cannot, you obviously go for the sine rule. Is this clear? Now let's try to attempt a few questions and then we'll move on to the area as well. Okay, class. Now the question is asking us to find the unknown side. Again, how do we check for it? Whether we can apply, again, first of all, it's not a right angle triangle, so we cannot apply SOHCAHTOA or Pythagoras theorem. We have to apply sine rule or the cosine rule. So if I want to find out side S, I'll first check for cosine rule. If I want to find one of the sides, I must know the remaining two sides and the angle of this side, corresponding angle of the side. Do I know the remaining two sides? Yes, class? Do I know the remaining two sides? Yes, bachon? Repeat, don't worry. So I'll repeat, don't worry. You have the sine rule and you have the cosine rule. Sine rule involves two sides and two angles. The cosine rule involves three sides and an angle. Always check for the cosine rule first. The first thing that you should see is whether it's a right angle triangle or not. It's not a right angle triangle, is it? Is this a right angle triangle?
No.
So I cannot simply apply the SOHCAHTOA or Pythagoras theorem. I have to go for sine and cosine rules, or what you categorize as further trigonometry. So if I were to find this side and I want to use the cosine rule, remember there are four quantities in cosine rule, three sides and the corresponding angle of the side. Okay. So I have three sides and an angle. Out of these four quantities, I must know the remaining three to find the fourth one. If I want to find out this side, I must know the remaining two sides and the corresponding angle. Do I know the other two sides?
Sir, you only know one side. You need to find out the second side.
Very good. So I don't know the other two sides. The moment I don't know the other two sides, I cannot apply the cosine rule. So ultimately, I'll end up using the sine rule. Is this clear or not?
Yes.
Okay, and what is the intelligent way to use the sine rule? Whatever is your unknown, you write that first. Just write S first. And you know you'll be using the sine of its angle S upon sine 58. So the side and the ratio of the sine of its angle. Is this clear? So start with the unknown. S is your unknown. So start with the unknown. S upon sine 58. S ke samne wala angle. The angle right in front of S. Sine of that angle. Now this will remain as it is. No matter what side or angle you choose. What other side and angle pair do you have?
16 and 37.
What goes in the numerator now?
16.
Very good. So 16 and sine of 37. No need to use the calculator at this moment. Sine 58 is dividing over here. You can just take it on the other side and it multiplies. So S will be 16 sine 58. I've already told you the calculator knows when you write it 16 sine 58. it takes the entire value of sine 58 and it multiplies it by 16 and then divided by sine 37. Now you use your calculator, you'll get relatively accurate answer without actually writing many decimal places. So you can write this entire thing in the calculator. We'll say 16 sine 58 divided by sine 37 and you get 22.5 centimeters. Is this clear, class?
Yes.
So now let's try to apply it on another triangle. If I want to find out side Q, do I know the remaining two sides? Yes, I know the angle that is in front of it, but do I know the remaining two sides?
No.
So I cannot use the cosine rule. I'm telling you, people always check for the cosine rule first. Is this clear, better? Because it is easier to check for. Now you can use the sine rule and you'll say that write the unknown first. Q is the unknown, Q upon sine of 69. And this will be equal to the ratio of side and the angle of its sine 40 upon sine 34.3. So Q is simply equal to 40 sine 69 upon sine 34.3. Is this clear, class?
Yes.
Easier to do, involves lesser steps, reduces your chances of error. So now put the entire thing in the calculator and tell me what do you get?
66.3 rounded up.
66.3.
3.
I'll be using your value, which is 66 point. Okay, again, we need to find the marked angle in these two parts. For the first one, I need this angle. And if I were to use the cosine rule and I need the angle, if the angle is the unknown, then all the three sides must be known. So if I want to find out this angle, do I know all the remaining sides? Do I know all three sides, Bache?
No.
No, so I cannot use the cosine. Ultimately, I'll have to use the sine rule because it is not a right angle triangle. I cannot use SOHCAHTOA. I just checked for the cosine rule. I cannot use the cosine rule. So I'll be using the sine rule. Now, what is the unknown, the side or the angle?
Angle.
So you write that first with the sine, obviously. Sine z upon, what is the value of its side? Corresponding side 18 is equals to what other angle and side pair do I have?
Sine 108 and 25.
Very good. So I'll write sine 108 in the numerator. Why? Because I'm writing angles in the numerator upon 25. No need to use the calculator at this moment. You can write sine z is equals to 18 sine 108 upon 25. If you want, you can convert this entire value into 4 or 5 decimal places. But how do you get z now? And sine goes on the other side, you write sine inverse, or you can do this entire thing in the calculator as well. The calculator will not be worried about calculating this entire thing. Is this clear, bache?
Yes.
That you can use the calculator smartly. You know that all of this is one single numerical value. You either find that value. Okay, if I'll do this with the value as well, let's see. Okay, I'll do it 18 sine 108 and divided by 24. So this is 0.6848. Or you could also do z is sine inverse of 0.6848. You can also do it this way. Or you could have just used this entire value, the calculator will give you the same answer. If you can do it this way as well, sine inverse of 18 sine 108. Make sure you close the brackets appropriately upon 25, or else you get syntax error in the calculator. 43.2 degrees. Both ways you will be getting the same value. Is clear, bache?
Ji.
So that is how you can smartly use the calculator, or you can just do sine inverse 0.6848. Will still give you the same value. Is this clear, beta? So both of them mean the same thing. Do not worry. Learn to use the calculator in a smart way. Now again, I need to find angle U. How do I do it? If I wanted to use the cosine rule, I must have known the remaining three sides. Do I know that?
No.
Obviously, so I'll end up using the sine rule. Right angle triangle तो है ही नहीं. Socrates and Pythagoras theorem were already out of the question. First, write the angle sine u. Obviously, the angle with sine upon. What is the side that I must write with sine u?
39.
Very good, 39. Now this will be equal to what? What other angle inside? Where do I?
93
Very
over
good.
46.
Brilliant. No need to use the calculator right now. 39 goes, it multiplies by sine 93 on 46. You can use this entire value as it is, or you can find its decimal value and then use it in the calculator. Both mean the same thing. On 46. Yes, class. So what is the value of u that you get?
$57.9.
7.9. What do you have?
9.
9. I just want to make sure that you people are not making the rounding off error. 39 sine 93 upon 46. 7.9 is the right answer. Very good. That's perfectly fine. Okay, now what about this? What do I need to find? I need to find the side S. What do you check first? Cosine. Right angle triangle to hai nahi. Socrates, Pythagoras theorem not needed. Sine or cosine rule, right? So first check for cosine. You want to find one side. You must know the other two sides. Do you know it?
Yes.
Do you know the angle, the corresponding angle, the angle that is right in front of the side? Do you know that?
Yes.
Yes, so you must use the cosine rule. How do you use that? Write s square first, your side first. 9 squared plus 13 squared minus 2, 9, 13 cos of 60. Now, in order to get s, you can put this entire thing in the calculator as well. Or if you want, you can find its decimal value as well. I'll show it to you both ways. Calculator will respond, but you have to be smart about it. So you will say 9 square plus 13 square minus 2 into 9 into 13 cos of 16. Get under root 133, and if you need the decimal value, 11.5. This is called exact value under root 133, and 11.5 is the decimal rounded off to 3 significant figures. Okay, again, you could have also done it this way. You could have figured out this entire value separately. That would be 133, and then you could have put the entire thing in your under root. Remember, I am constantly reminding you these four quantities are multiplying 2, 9, 13 and cos 60. So just be careful with this. Is this clear, bache?
Yes.
What about this one? You want to find side P, so it's not a right angle triangle. SOHCAHTOA and Pythagoras theorem cannot be used. Let's go to sine rule or cosine rule. Check for cosine rule first. Can you apply it?
Yes.
Yes, you can. If you want to find side P, you know the remaining two sides and the corresponding angle of P, the angle that is right in front of P. So P square is 8 square plus 5 square minus 2, 8, 5 cos of 1. I will let you people do this one and tell me the answer. Yes, class. What is the answer for this one?
$12.3.
Sorry?
12.3.
Now, what about this one? You want to find the angle R. Always check for cosine rule first. Do you know the all remaining three sides?
Yes.
I'll just write it for you so that you understand how do you use it if you were to find out an angle. You can either manipulate the first one again and again, or you can write cos R. Okay, now you need R, angle R. So the side R will just be used once. P square plus Q square minus R square. That's it, upon 2PQ. It will take a while. Do not expect that you will be very fluent with all these rules with just one or two questions. This will take a while. I've told you if you want to manipulate the entire thing on your own, you can do that too. You just keep one in your mind and manipulate the entire thing, bring it over here, take the a square over there and divide it by 2bc, you eventually end up getting this. So again, you're using the cosine rule. Find out the values. 10 p square is 8. Let's write first 8 square plus 10 square minus 12 square upon 2 into 8 into 10. Now you can put this entire thing in the calculator. The calculator will give you a fraction. If you want to write down the entire fraction, you can do that too. So that is 8 squared plus 10 squared minus 12 squared upon 2 into 8 into 10. That is 1 upon 8. So R is cos inverse of 1 upon 8. Yes, class. So what is the value of the angle R?
82.8.
Very good. I hope you people are writing it down as well and not just using your calculators to tell me the answers. Again, if you were to find the angle F, not a right angle triangle, first check for the cosine rule. Do you have all the remaining three sides?
Yes.
Also, you apply cosine rule cos F and we need the angle, right? Side F will just come once. That is all I am worried about. G or H का कोई मसला नहीं है. G square plus H square. I can write it in any order. That doesn't matter. But F square is what I should be focused on. 2F, yeah, 2GH. Now, can you apply the entire thing and let me know the values of F that you get? Yes, trust you with your answer. It's 99.4. I just tried to answer this. You can do any of that. Is this clear, class?
Yes.
And let's just try to do some other problems involving sine and cosine. Okay, class. Now, how do I find the length of its diagonals? I need to find the length of its diagonals. One of the angles given is 60 degree, which is a parallelogram. We have studied the topics of angles because we knew we would be needing them in this topic. Yes, class. How do I find the length of a diagonal? Let's just try to find the length of the first diagonal. How do I do this? How do I find the length of this one? Now, is this a triangle?
You use cosine rule
Yes.
for length.
Very good. You need to find this length. So what did you check for? You knew the remaining two sides and you knew this angle. This is a triangle that you formed. So let me call this diagonal. Let me call this diagonal one. This is D1. I'm just calling it. One is the smaller diagonal, one is the larger diagonal. I'm calling it S smaller diagonal. So I'll use S square is 70 square plus 30 square minus 2 into 70 into 30 cos of 60. Now you can underroot the entire thing and tell me the value of the smaller diagonal. Yes, class. What is the value of the smaller diagonal?
$60.8.
Sorry, 60.8.
Yeah, 60.8.
What about the large diagonal? I'll be calling it L, large diagonal. Remember, this is a parallelogram. There are interior angles in parallelogram. This is 60. So how do I get this angle, this entire angle? How do I find the value of this angle? Yes, class. Forget about the first diagram so that there is no confusion. If this is 60, this will be 120. It is the supplementary of 60. These are called interior angles. The angles that are formed between two parallel lines on a transversal line, and their sum is equal to 180 degrees. So if this is 60, you subtract 60 from 180, this will be 120. Or even you can take the top one as well, that will also be 120. Now you have 70, you have 30, and you have the angle 120, and you need to find the angle of the larger diagonal. Again, you'll use the cosine rule. 70 square plus 30 square minus 2, 70, 30 cos of 1. This class, so what is the length of the larger diagonal?
$88.9.
So 88.9, not degrees, sorry, it's 88.9 centimeters, sorry. Is this clear, class?